we're going to find the inverse of matrices and the determinant of matrices. So we already mentioned before that you do the matrices by, the order is rows by columns. So this is 2 rows by 3 columns. This one's a 3 by 3 matrix. So in order to do what's called the inverse matrix, it has to be a square matrix, meaning the rows and columns have to match. It has to be a 2 by 2 matrix, a 3 by 3 matrix, a 4 by 4 matrix. So you have to have a square matrix. Rows and columns are matching. Okay, now the identity matrix is where you have ones down this main diagonal and zeros in all of the other spots. So basically, if you took the identity matrix and multiplied it by another matrix, then you come up with the answer of that other matrix. So when you multiply by the identity matrix, it's kind of like timesing something by 1. It doesn't change the answer when you multiply. And when you have the identity matrix, it doesn't matter if you do the identity matrix times the other matrix or the other matrix times the identity matrix, it still comes out as what they're saying here, matrix A. So it's called the identity because you can multiply it to other matrices and still come up with whatever that original matrix was. Okay, so if you have 2 matrices, if they are inverses of each other, then you come up with the identity matrix. So this one says determine whether A and B are inverses of each other. So if I want to know if they're inverses, A and times it with matrix B, and then if I did matrix B times matrix A, both ways I would end up with the identity matrix if they are inverses of each other. So as a reminder, the way we learned to multiply last time, again I'm doing it by hand, not on the calculator right now, is I would take the first row, so if I was going to do matrix A times matrix B, I take the first row in matrix A and turn it sideways, so that would be a 3 and a 2. And then I go 3 times 5 gives me 15, plus 2 times negative 7 is negative 14. And then I take that and times it to the second column, so 3 times negative 2 is negative 6, plus 2 times 3 is 6. And then I would take the second row, turn it sideways, and multiply. So 7 times 5 is 35, plus 5 times negative 7 is negative 35. And then I times to the next column. 7 times negative 2 is negative 14, plus 5 times 3 is 15. So now if I added those together, 15 plus negative 14 is 1, negative 6 plus 6 is 0, negative 35 plus 35 is 0, negative 14 plus 15 is 1. So I did end up with the identity matrix. Now it has to work both ways. So now if I took matrix B and times it with matrix A, I want to know, do I still end up with the identity matrix? So now I'm starting with matrix B. So I take the row on matrix B, turn it sideways, and then multiply it into the matrix A. So I would be going 5 times 3 is 15, plus negative 2 times 7 is negative 14. 5 times 2 is 10. Negative 2 times 5 is negative 10. And then taking the next row, negative 7 times 3, so that's going to give me negative 14, plus 3 times 7 is 21. Sorry, that was negative 3. That shouldn't have been 14. Negative 7 times 3 is negative 21. And then 3 times 7 is 21. Times to the next column, negative 7 times 2 is negative 14. 3 times 5 is 15. So then when I add these together, I end up with a 1, 0, 0, 1. So I do know for sure that A and B are inverses of each other, because when I times, I do get the identity matrix out. Okay, now it says, now we want to find the identity matrix and then show that it's equivalent. So we already know that matrix A and B are the identities. If you multiply them, you get the identity matrix. But if they gave you just matrix A and you didn't know what matrix B was, the way we can find it is you take the matrix they gave you, and then you draw a line, and then you write the identity matrix on the other side. So on the other side, the identity matrix, 1's down the main column, or main diagonal, and 0's in the other two spots. So now what we're going to do is we're going to do operations on this matrix like we learned how to do last time, and try to change it so this first matrix over here becomes the identity matrix, and then over here it should end up being matrix B. So this is how we find the identity matrix. So if I wanted to get 1's down the main diagonal, I want to end up with 1's there. So what I usually try to do is, if I wanted to make this a 1, actually before I make that a 1, because I'd have to divide by 3 and I'm going to get fractions and I don't want to deal with that right now. So what I could do is I could try to make this one right here become a 0, and then once that's a 0, then I'll go from there. Okay, so if I wanted to make a 0 where that 7 is, I could times the top row by, say, -7, and I could times the bottom row by, say, 3. So I'm going to go -7 times my top row, and then I'm going to go plus 3 times my bottom row, and then that result I'm going to make my new bottom row. So when I times the top row by -7, I get -21, and then I get -14, and then 7 times 1 is -7, and then 7 times 0 is 0. Now when I times 3 into this next one, I'll get 21. 3 times 5 is 15. 3 times 0 is 0. 3 times 1 is 3. And that's going to now become my new bottom row when I add these together. So adding these together, I get 0, and then -14 plus 5 is 1, -7 plus 0 is 7, -7 and 0 plus 3 is 3. Okay, now I'll go ahead and go to my top row. I want my top row for it to become a 1 right where that 3 is. So I can make that become a 1 by timesing the top row by, say, a positive 1/3. So I'm going to do row 1 times a third, and that's going to become my new row 1. So a third times 1 gives me 1. A third times 2 gives me 2/3. A third times 1 gives me 1/3, and then a third times 0 is 0. Okay, so now my goal, I now have 1's down my main diagonal, but I need 0's in the other two spots. So I already have a 0 here, but I need to get a 0 where that 2/3 is. So if I need to get a 0 there, I can now take my bottom row, and if I times my bottom row by -2/3, then I'll be able to add it to the top row and get a 0 right there where that black 2/3 is. So my next operation is going to be 2/3 times row 2, and then I'll add it to row 1, and that will become my new row 1. So timesing the bottom row by 2/3, -2/3 times 0 is going to be 0. -2/3 times 1 is -2/3. -2/3 times 7 will be positive 14/3. And then -2/3 times 3 will be -2. Now adding this green and black together and making that my new row 1, 0 plus 1 is 1. The -2/3 and positive 2/3 cancel, becomes 0. 14/3 plus 1/3 would be 15/3. 15 divided by 3 is 5. -2 plus 0 is -2. And then I didn't do anything to the bottom row, so it stays as 0, 1, -7, and 3. So now the left hand of my matrix is the identity matrix, and then the right hand is supposed to be what the inverse of A is, which is the 5, -2, -7, 3, which is what we had verified on the first page. Okay. So if you make the original matrix, change it into the identity matrix, then it gives you what its identity matrix is. What its inverse matrix is. Okay, so now if I needed to find the inverse matrix of a 3 by 3 matrix, I'll do what I did on the previous. So I'm going to draw a line right here. I'm going to put 1's down the main diagonal and 0's in all of the other spots. And now I'm going to do operations to change that first matrix into the identity matrix. So if I wanted to get, say, a 0 right here where that 4 was, I could go and times my top equation by, say, a positive 2, because then I'd get a negative 4 and I could add it to this. So I'm going to do top row, row 1 times 2. I'll add that to row 2, and then the answer I get, I'm going to make my new row 2. So when I multiply, that's going to give me negative 4, and then 2 times 4 is 8, 2 times 1 is 2, 2 times 1 is 2, 2 times 0 is 0, and now I'm going to add my row 2 with this new row 1. So then that will become my new row 2. I'll just put it right here. So then 4 plus negative 4 is 0. Negative 13 plus 8 is going to be negative 5. 10 plus 2 is 12. And then 0 plus 2 is 2. 1 plus 0 is 1. 0 plus 0 is 0. Now I want to get a 0 where the 3 is. So to do that one's going to, I'll have to multiply 2 rows, so that one's going to be a little bit more tricky. I can use either the top row or the middle row. It doesn't matter which one. I'm just going to choose to go with the top row. So if I have a negative 2 and a 3, I want to get a 6. So I could times the top row by, say, a positive 3, and then I would get a negative 6. And I could times the bottom row by a 2, and I would get a positive 6. So I'm going to go 3 times the top row, and then I'll add that to 2 times the third row, and that will become my new third row. That looks like a negative 3, but that should be a positive 3. Okay, so now multiplying in, 3 times negative 2 is negative 6. 3 times 4 is 12. 3 times 1 is 3. 3 times 1 is 3, and then 3 times 0 is 0. And then on the bottom row, 2 times 3 is 6. 2 times 9 is negative 18. 2 times 6 is 12. And then 2 times 0 is 0, and then 2 times 1 is 2. So now I'm going to add those together, and that becomes my new bottom row. So negative 6 plus 6 is 0. 12 plus 18 is negative 6. 3 plus 12 is 15. 3 plus 0 is 3. Add the zeros, I get 0. 0 plus 2 is 2. Okay, now I could go ahead and times the top row by negative 2 to get the top row to cancel, but then I'm left with fractions, so to get a 1 in that top spot. So I'm going to leave it right now because I don't want to introduce fractions quite yet. So the next thing I'm going to try to do is to get a 0 where the 6 is. So to get a 0 there, I look between, so I'm going to leave my top row as negative 2, 4, 1, 1, 0, 0. So to get a 0 where the 6 is, I need to use the middle and the bottom row. So to get a 0 there, I have a negative 5 and a negative 6. So if I can make them one become a 30 and the other one a negative 30, then I can add them together and get a 0 in that third row. So I'm going to choose to times, say, this middle equation, that middle row, by, say, negative 6, then I'll get a positive 30. If I times the bottom row by, say, 5, then I'll have a negative 30, and then I'll be able to add them together. So I'm going to do negative 6 times row 2, add it to 5 times row 3, and I'm going to make that my new row 3. So when I times negative 6 times 0, I get 0. Negative 6 times 5 is 30. Negative 6 times 12 is negative 72. Negative 6 times 2 is negative 12. Negative 6 times 1 is negative 6. Negative 6 times 0 is 0. And now timesing the 5 in, 5 times 0 is 0. 5 times negative 6 is negative 30. 5 times 15, let's see here, 60, 75, I think. 5 times 3 is 15. 5 times 0 is 0. 5 times 2 is 10. So now I'm going to add those together, and that's going to be what I put in my row 3. So 0 plus 0 is 0. 30 plus negative 30 is 0. Negative 72 plus 75 is 3. Negative 12 plus 5 is 3. Negative 6 plus 0 is negative 6. 0 plus 10 is 10. Okay, now I need to get now I'm going to go ahead and get, well, maybe I'll still leave that. I still don't really want to divide by -5 because I really don't want fractions. So I'm going to still just kind of leave this for now. Okay, now I'm going to go ahead and I want to get a 0 where the 12 is. So if I want to get a 0 where the 12 is, I can use my bottom row. And if I times that 3 by a -4, I would get a -12. And then I could add them together and get a 0 where that 12 is. So I'm going to go -4 times my bottom row. I'll add that answer to my middle row, and the result will be my new middle row. That should be a 2 right there. That still doesn't look like a 2. So multiplying the bottom row by, say, -4, I get 0, 0, -12, and then -12. -4 times 6 is 24. -4 times 10 is -40. Now I'll add the middle row with this new bottom row. So then my new middle row will be 0 plus 0, which is 0, -5 plus 0, which is -5, 12 plus -12 is 0, 2 plus -12 is -10, 1 plus 24 is 25, and then 0 plus -40 is -40. Okay, now I'm going to go ahead and get, let's say I want, the next thing I would want is a 0 where this 1 is right here. So if I want to get a 0 there, I could take my bottom row. If I take my bottom row, since this actually works because I want eventually that bottom row right there to be a 1. So I can go ahead and multiply everything by 1/3, and that would give me a 1. And then if I then times everything by a negative, then I'll be able to cancel with that top row. So, but I'm just going to do the bottom row by 1/3. So if I do 1/3 right here and make that my new bottom row will become 0, 0, 1, and then 1/3 times 3 is 1, 1/3 times -6 is -2, and then this one will be 10/3. And then while I'm at it, I might as well go and times, say, this middle row by -1/5, because if I times this by -1/5, then I'm going to get a 1 right here where this -5 is, because again, my ultimate goal is to have this row to be a 0, 1, 0. So if I times this row by -5, I'd get a 0. -1/5 times 5 is going to give me a +1. And then a -1/5 times 10 will give me a 2. And then -1/5 times 25 will give me -5. And then -1/5 times -40 will give me +8. Okay. Now I want to get a 0 on this top row right where that 1 was. So now if I times my bottom row by -1 and added it to the top row, then I would get a 0. So I'm going to times this by -1. So I'm going to take -1 times row 3, add it to row 1, and that's going to become my new row 1. So when I times this bottom row by 0, I get 0, by -1 I get 0, 0, -1, -1, +2, and -10/3. So now I add that to my red top row, and I get -2, 4, 0, 0, 2, -10/3. Now on that top row, I want to get a 0 where the 4 is. So to get a 0 there, I could just times, say, my middle row by a -4. So that middle row, when I times, becomes a 0, -4, 0, negative 8. The negative 4 times 5 is 20. Negative 4 times 8 is negative 32. Okay, now I'm going to add that to my top row. So then my top row becomes negative 2. Negative 4 plus 4 is 0. 0 plus 0 is 0. Negative 8. 20 plus 2 is 22. And then negative 32 minus 10/3. I think that says negative 106/3, hopefully. Okay, and then my middle row is still going to stay 0, 1, 0, 2, negative 5, 8, 0, 0, 1, 1, negative 2, 10/3. Okay, I'm almost done. The last thing I now need to do is make that first negative 2 become a 1, and then it's the identity matrix. So to make this become a 1, I could just times everything by negative 1/2. So now I get 1, 0, 0. Negative 1/2 times 8 is 4. Negative 1/2 of 22 is negative 11. And then times this answer by negative 1/2. And I get, I think that says 53/3. And then I would have 0, 1, 0, 0, 0, 1, 2, negative 5, 8, and 1, negative 2, 10/3. Okay, so assuming I didn't mess up anywhere in that long process, the inverse of matrix A would be this matrix right here. Okay, now I'm going to do it in the calculator, and we'll see if I messed up anywhere. Okay, so in the calculator, if you go back on the calculators I recommended you guys to get, mode, and then I think this was your matrix, you're going to go ahead and edit your matrix A. So my matrix, the original matrix A, clear up here somewhere. Okay. So on my calculator, I'm going to go second matrix, arrow over to edit, and then pick whatever matrix you want to edit. I'm going to do matrix A. My matrix A was a 3 by 3 matrix, 3 rows by 3 columns. Oops. And then you just type in the numbers of the matrix before we start. Oh, come on, calculator, work for me. Okay. Okay, so then you're just going to type in the numbers from the original matrix A. Just hit enter or equals after each number, and it automatically moves you over. Make sure you hit enter after this last, after I typed in the 6. If you don't hit enter, it doesn't actually change it from what was already there. So make sure to hit enter. And then once you have it typed in, then we have to get out of the matrix to our main screen. So for you guys, I think you can just like hit clear or comp 1 or something. Just hit something to get out of your matrix. I hit second quit for mine. And then once you're back to the main screen, then on your guys' calculators, I think it's like shift and then 4, whatever number has the word matrix above it. So on mine, I hit second and then the X with the -1 because it says matrix. And then I'm going to go ahead and select my matrix that I just edited. And then once you have your matrix there, you hit the button that says X to the -1. So find that on your calculator somewhere because that's the inverse button. And then I hit equals. And then it tells me this matrix. Let me change this to a fraction so I can compare it to my fractions. Okay, so now if I come back down here and compare, 4, -11, 53/3, 2, -5, 8, 1, -2, 10/3. So I did manage to keep all of my math correct through that big, long process, and I now know that I was able to come up with the correct inverse matrix. Now, just so you're aware, the inverse matrix doesn't always exist. So it is possible I could have been like going through this big long process to try to find the inverse matrix. And then maybe at the end here, maybe I couldn't get ones down the main diagonal. Maybe I got like 1, 0, 1, 0, 1, 0, and then like 0, 0, 0 or something. But sometimes you just can't get that inverse matrix on the left-hand side. Okay, it doesn't have to be possible for there to be an inverse matrix. So if it doesn't exist, it's called the singular matrix if it doesn't have an inverse. So if I tried this one on the calculator, so I'm not going to try to work it all out by hand, but I could, but it takes forever. I would go matrix, so get into wherever your matrix button is on the calculator. It's a 3 by 3 matrix. And then just type in the numbers. And then again, after you hit enter, get out of your matrix to the main screen, and then go and click into the matrix that you edited. Hit the inverse button. Singular matrix, error. There is no inverse for this one. So then you would just select it doesn't exist or whatever they ask you to do in Delta Math. But there is no inverse matrix. That means there is no matrix I can times to matrix A that would give me the identity matrix. Okay, now determinants. Again, I'm going to do this by hand first. So if it's a 2 by 2 matrix, it's easy to find the determinant by hand. Oh, and it says determinants have many applications in math, including solving a system of linear equations, finding the area of triangles, determining if the 3 points are collinear, finding the equation of a line through 2 points. So there are applications for determinants. Okay, so if they want you to do the determinant, they put around the matrix like these absolute value looking signs. So usually when we do matrices, we have these little brackets. But if they put them inside these bars that look like absolute value, that's the notation to say, oh, we want you to find the determinant. So you're not doing the absolute value of it. You're not like taking the numbers in it and making them positive. That just means we're doing this determinant. So if it's a 2 by 2 matrix, to find the determinant, what you do is you multiply diagonally down the main diagonal. So I multiply down the main diagonal, and then I go minus, and then I multiply the other way. So sometimes, like we might on one of the pages have like letters A, B, C, D. So the formula would be I multiply the A and the D together, then I go minus, and then I multiply the C and the B. So I don't try to like memorize a formula. I just know times diagonally this way, minus times diagonally the other way. So if I times diagonally the 3 and the 0, I'd get 0. Then I go minus, and then I multiply the 4 with the negative 1, which gives me negative 4, and then that would be 4. So I now know my determinant is 4. Sorry. No, it's okay. And since I didn't record it, I'll just quickly repeat what I said. So A times B minus the B times C. So multiply diagonally down one way, and then minus diagonally the other way. Okay, and then there's that little formula that I just used. So if I wanted to find the determinant of this one, I would go negative 7 times 6, which gives me negative 42, minus 2 times 1, which is 2, and then that gives me negative 44 for my determinant. On this next one, I would just go 3 times 2, which is 6, minus, and then 10 times negative a half would be negative 5. The minus and the negative become a positive, so then that determinant is 11. So not too bad if they're just a 2 by 2 matrix. If it's bigger than a 2, oh, and just let me go back one. You might not see any of these on your assignment, but like sometimes on ACT tests, they might give you like something like this with letters in it. So it might say like 3, A, 10, and 2, and they might say this equals 5, and then they might say what's the value of A? Well, knowing that those two lines mean that they want the determinant, I know this left-hand side of the equation would be 3 times 2, which is 6, minus 10 times A, and then it says it equals 5, and then lo and behold, you then have an equation to solve, and you can actually find out what that A missing value would be. Like just minusing 6 to both sides of the equation, I get negative 1, negative 10A, so then I divide by negative 10. So now I know my A would be 1/10. So sometimes I've seen on standardized tests where they put an unknown in there and then ask you to solve and find out what it is. So they can add to it, then just say find the determinant. Okay, now if it's a 3 by 3 matrix, there's two different ways that I know of to work it out, and I'm not sure which way Alex is going to teach you. They have this way up here, which is the way that I don't like to do. I'm going to teach you guys this way, but again, I don't know if you're looking at the Alex which way they're going to show, okay? But I'm only going to teach the bottom way because to me that's the way I like, okay? But if this doesn't make sense to you and you read through Alex, then you can learn the other way. Okay, so this other method says, and by the way, it would have worked with a 2 by 2 matrix also, but the 2 by 2 matrices are easy enough that you don't need to. With 3 by 3 or bigger, 4 by 4, 5 by 5, 6 by 6, this other method says what you're going to do is, you're going to take these first 2 rows and you're just going to repeat them. So let me redraw this matrix down here. Just drag that. Good. Okay. So I'm going to take the first 2 rows in this matrix and I'm just going to rewrite them. Sorry, the first 2 columns. So it would be a 2, a 4, a 1, a negative 3, negative 5, and a 5. So I just repeat them. Now, if it was a 4 by 4 matrix, I'd need to write the first 3. Okay, so as your matrix gets bigger, you have to do more rows. So what you're going to do, and I usually just immediately grab out my calculator. So I'm going to write all the steps on the board, but you guys pull out your calculator and just like type them in the calculator, because I usually am just typing this in the calculator, not putting it on my board. So what you're going to do is we're still going to multiply diagonally, but now I have to multiply diagonally 3 times going across. So I'm going to multiply diagonally these 3 numbers, so the 2, the negative 3, and the negative 1. So this is where I'd be grabbing my calculator, and on my calculator I'd be going 2 times negative 3 times negative 1. Then I go plus. And then I'm going to go to the next one. Multiply diagonally those 3 numbers that are in that diagonal row. 4 times 0 times negative 5. And then I'm going to go plus. And then that last column would be the 2, the 1, and the 5. And then I start going minus. So now I don't have enough room to go there, so I'm just going to go on to the next row. So then I go minus, and now I'm going to start multiplying this way. So then it's going to be negative 5, negative 3, and 2. And then I'm going to go minus. And then I'm going to multiply diagonally the next 3. The 5, the 0, and the 2. And then I'm going to go minus. And then the next 3. Negative 1, 1, and 4. And then so you type that whole stream into your calculator, and then you just hit enter. And hopefully some of you guys did that. What number are you guys getting out? 34. So now I know my determinant is 34. So you just have to rewrite enough of these columns so that you can multiply with that last one diagonally. 26? Okay, so it could be 34, could be 26. Anyone else get an answer? Different answer for anyone? Okay, we're going to now check it in the calculator and we'll find out, was it the 34 or was it the 26? Okay, hopefully it was one of those two. Okay, so in the calculator, I go back to where I edit in my matrices. So you guys mode 6 or whatever one says matrix. So I'm going to go second matrix on my calculator, arrow over to edit. And it's still a 3 by 3 matrix. So 2, 4, 2, 1, negative 3, 0, negative 5, 5, and negative 1. And then again, make sure to hit enter after that last number. And then get out of your matrix. And then go second matrix or shift matrix. Now don't grab the matrix you edited yet. We have to find the determinant. So on mine, I'm going to arrow over to math, and I'm going to find the one that says DET. On you guys, when you're in the matrix, it should, can I see your calculator?
It's number 7.
Number 7. Okay, so when you're in the matrix, hit number 7. Just find that DET button. So after you found the determinant, then you go shift matrix again, and then grab the matrix that you edited. So you have to get the determinant in there first or it doesn't work. And then you hit enter. Our determinant was -10, so it was neither of those. You got -10? I think a lot of people now being willing to say they got -10. Okay, so -10 was our answer. So you just have to be really careful when you're typing it in your calculator when you're doing it by hand, because it's really easy to miss a number. Okay. So those of you that have the calculators that do determinants, you know, you can get them quicker. I would just practice a couple to make sure you have it down. But if you don't have the calculator that does it, this is the process. Just be very careful typing in your numbers. Okay, so if you did have to do it by hand, again, you would repeat the first 2 columns. And again, we times diagonally this way, so it would be -2 times -1 times 6 plus times this way, 4 times 2 times 1 plus times this way, 9 times 5 times 1. And then when you start multiplying the other way, you just start putting minuses in between. So 1 times -1 times 9 minus 1 times 2 times -2 minus 6 times 5 times 4. And if you type that all into the calculator carefully, I'm just going to go to the matrix so we don't end up with the wrong answer initially. Still a 3x3 matrix. And by the way, if it's a 2x2 matrix, you can do it this way too, but on a 2x2, I think it takes longer to edit the matrix and go and find the determinant button than it does to just times diagonally down one direction and then the other way. Okay, so now hopefully that answers -42.